Good morning, folks. Hope you all had a fantastic weekend. Unfortunately, I'm not here today. I'm not feeling too hot. I'm going to check for a few things and see what's going on. But hopefully, keep your fingers crossed. I should be back tomorrow. Okay? Those of you who were in the play today, good luck. All right? Still planning on being there the 24th to see how it goes. I can't wait. But anyway, today, folks, we're going to be doing lesson 510. All right, now what you should be completing during class is watching this video, completing the sub-assignment, and completing the practice problems or the homework problems for 510. All right, you should have time to do that in class today. All right, all of that, every single one of those items can be found on the Week at a Glance under Monday. If you're watching this video, you've probably already seen them. Okay, so let's get started on that video. So today we are talking about, well, our ICANN statement, if you look up at the board, right, is to create graphs of nonlinear functions with pieces of linear functions. So if we look at the starter, what you might notice is that, well, first of all, there's a lot of, what are some things you notice? Think about that for a second. Pause the video. Okay, and then push play. All right, see, I can talk about it. What you might notice is that there's a lot of dots, right? We've got kind of a slope that's going up and a slope that's going down, right? A positive and a negative slope. Okay, you might also realize that we kind of have two lines here, right? Like this sectional line is a linear function. This section of line is a linear function. The lines together make a nonlinear function. So this is what a piecewise function is. The reason they call it a piecewise is because it uses pieces of linear functions to graph a piecewise function. Okay, so we've got this piece here and this piece here. Ta-da! That's what we're looking at today. Okay, so we've looked at this model of recycling before, right? It's asking us to approximate the percentage of recycled materials each year with a piecewise linear function. What that means is it wants you to draw 3 and 5 line segments to approximate the graph. We did that in one of the classes last week with this, right? It said from 1990 to 95, we can approximate using that line. Now, if you want to go 3 lines, it would make sense to make maybe a line right here and another line right there, okay? It did also say 3 to 5, so it would be acceptable to do something like this, okay? Now those pieces, those 4 different pieces I've drawn, do approximate the line pretty well, okay? And we can use this to make kind of calculations. We can use this to make predictions, right? So I can say at 2005, well, my line's right on that point, but about 23% of garbage was getting recycled, okay? Using the line's prediction here, I could say around 25%, maybe a little bit higher than the actual point. That's okay. Okay, but from this, I can tell that my garbage, the percent recycled was increasing about 5% or 6% over between the years 1990 and 95. See what I did there? I looked at the slope. Okay? For the next part of my piece was I could say over the next 10 years, right, it only increased at a rate of about 2% over the course of 10 years. See how it looks like we went from 21 to about 23. And you could say maybe not over 10 years, but perhaps over like 7. Okay? And for the next 7 years, right, it increased to about 5% over those 7 years. Okay? So what piecewise functions do is they kind of allow us, right, to generalize our data, right, so that we can use unit rates, right, to describe what's going on in the situation. Okay, so I can describe how the rate of garbage changed. Okay, it was doing really good in 1990 to 95, right? Maybe check out Give a Hoot, Don't Pollute, or some of the recycling things. In the 90s, people were really big into recycling, the late 90s especially. But it looks like things slowed down. We sped up, and then we got really bad at it in 2010. Okay, interestingly enough, right? Cool. Okay, so something else I want you to look at, right, is we can draw our own piecewise functions. All right, and this is the last thing we're going to look at. Is it? Let me double check. Yeah, it is. Okay. So here we've got most of our piecewise functions we'll be looking at look like this. Okay. Where Elena is filling up a tub and giving her dog a bath. Okay. And then she let the water out of the tub. Well, we can see that on the graph, right? If we've got water level as a function of time, we can kind of follow the graph. We can say, all right, from 0 to 6 minutes, okay, she was filling up the tub at a rate of about 24 gallons every 6 minutes. So 1 gallon every 4 minutes. Sorry, 6 gallons every 4 minutes. Not bad. Okay, that's the slope of that line right there. And then what happens here? What do you all think that's happening? Which is probably giving the dog a bath because the level of water in the tub is not changing. She does that for about, well, I'm going to say minutes, 6 to 18 minutes. Okay, so about 12 minutes. And then she empties the tub at a slower rate than it was filled, I might add. Okay, so we can tell all these things by this piecewise function, but also note there's 3 different linear functions here. Okay, for those 3 different points, we can identify the rate of change or the slope, right? This tub was being filled up at a rate of 12 gallons every 3 minutes. 12 over 3, okay, or 4 gallons every 1 minute. All right, tub didn't change here. The water level stayed the same. And then it was draining at a rate of about 24, 18. Okay, so that's 6 gallons every 3 minutes. So 2 gallons per minute. Okay, ta-da. That's the lesson today. I also wanted to add, I wanted to add one more thing. Okay, very, very important that we talk about what is a function. We've done this in passing. We did it on lesson 4, but there wasn't any practice problems with it. So I've included a couple of these problems in your sub-assignment today. Pretty much all I want to say is that, look, this table shows us a function, right? Because the main rule of a function is that every input has just one output, right? So the input of 0 has 3, the input of 1 has 4, the input of 2 has 18, the input of 3 has 17. The input of 4 also has 17, but 3 and 4 still just have one output, right? So this is a function, okay? Now, this one, let's check this out. Let's see if this is a function, right? 0 has an output of 1, 2 has an output of 2, 2 has an output of 3 as well, 4 has an output of 4, and 6 has an output of 5. Is this a function? It is not. Okay, here's the main reason why. Here's the only reason why. Okay, 2, the input of 2 has 2 different outputs. So we don't know for sure which output it is, or which output we're going to get if we input 2, okay? That is the main idea of the lesson today. I hope you all have a fantastic day. Those of you performing, go break a leg, knock everybody's socks off. Y'all are going to do great, okay? Everybody not performing, be a good audience, all right? Have fun. All right, I hear it's a great show. I've heard from a lot of the students, so can't wait to see it on the 24th. Sorry I'm not here today. All right, but y'all have a great day. Be good for the sub, and we'll see y'all tomorrow, hopefully, okay? Mr. Whale signing off. Bye.